All right, we are doing function inverses today, and we are going to be doing the classwork. Now, for each function f of x that I give you, we're going to be finding its inverse function, and then we're going to verify that they actually are inverses by doing function composition. If for some reason f of x does not have an inverse, we need to explain why that it doesn't. So let's work on number one. Okay, so number one says f of x is equal to 2x minus 8. So this is the function that we're given. We're given f of x, and we want to find its inverse. And we're going to display the inverse by f negative 1 of x. So we want to find its inverse. What we're going to start off by doing is replacing f of x with y. So we're going to replace f of x with y, but we're going to keep everything else the same. So what did we just do? We replaced f of x with y. So that's the first thing that we always do. We take that f of x and we replace it with a y. The next thing that we're going to do is we're going to interchange x and y. So what that means is everywhere you see a y, you're going to change it to an x, right? And everywhere you see an x, you're going to change that to a y. Get it? So this x is going to become a y, but everything else is going to remain the same. So you're still going to have that 2 out in front of the y, and you're still going to have that minus 8. So what did we do? We interchanged x and y. That just means we switched them. Okay, so now what we want to do is we want to get y by itself. We want to solve for y. So basically, we're trying to get y by itself now. We need to get rid of the minus 8 first, and then we're going to get rid of this 2 that's out in front. So to get rid of a minus 8, I'm going to add 8 to both sides. So that way, what happens is the minus 8 and the plus 8 cancel out. And I'm only left with a 2y on this side. On the other side, I'm going to have x plus 8. Okay, so now the only thing I have left to do is to get rid of this 2 that's out in front. How can I do that? I'm going to divide both sides by 2. So when I do that, the 2's cancel out, and I'm left with y is equal to x plus 8 over 2. So x plus 8 is going to be the top of the fraction, also known as the numerator, and the 2 is going to be the bottom of the fraction, also known as the denominator. So what did I just do in that step? In that pretty long step, what I did was I solved for y. So I solved for y. So now the last thing that I need to do, my fourth and final step, is going to be to replace y with f negative 1 of x, which is way up here. So I'm going to replace y with an f negative 1 of x. And that just means inverse of f, my inverse function. So that's going to be x plus 8 all over 2. And we're done. That's our inverse function. So if our regular function was f of x equals 2x minus 8, then our inverse function is going to be x plus 8 over 2. And these functions kind of undo each other. Now, our last step was to replace y with f negative 1 of x. So that's the last step we're going to do in each one of these problems. Okay. So we're going to take both of these functions, and now we have to verify that they are indeed inverses. And we're going to do that by composition on the next slide. Okay, so to verify, what I'm going to do is I'm going to start off by listing both of the functions. My f of x was 2x minus 8, and my f negative 1 of x was x plus 8 over 2. So now what I want to do is I want to compose them together. And what that means is I'm going to be taking f of negative 1 and I'm going to be composing that with f. And when I evaluate this composition at x, I should get x in return. So we're going to see if that's actually true. Now, when we compose these two functions, what's going to happen is I'm going to write out f negative 1 first, and then I'm going to write f next. That's going to be inside the parentheses. So now what I'm doing is I'm evaluating f inverse at f. So I'm still going to have f inverse. And inside here, I'm going to have f of x. Well, what is f of x? It's up here, right? 2x minus 8. So I'm going to replace the inside with 2x minus 8 and see what happens. So now what I have is I have f inverse of 2x minus 8. So that means now I'm looking at f inverse, this function over here. Now keep in mind what this means is I have to replace every x up here with a 2x minus 8, right? I need to replace the x with a 2x minus 8. So when I do that, I'm going to get 2x minus 8, right? That's going to be my x. But then I have to add 8, so I'm going to be adding 8 on top. And what am I going to be dividing everything by? This 2 right here. So I'm going to put a 2 in the denominator. Okay, so really quickly on top, the negative 8 and the positive 8 are going to cancel each other out. So I'm just going to cross them out. And what am I left with at the top? I'm left with a 2x. And I still have a 2 on the bottom. But when I divide 2 by 2, those are going to cancel out to give me 1. So if the 2's cancel out, I'm just left with an x. And I'm done. So I was trying to figure out if when I verified this, the two functions, when I compose them, give me x. And that, of course, is true. So I can get rid of the question mark up here. Okay. Now let's try number 2. Okay. So number 2 says, let g of x be x plus 2 over 3. All over 3. And I need to find g negative 1 of x, right? I need to find the inverse of g of x. So what am I going to do first? I'm going to replace g of x with a y, because I can always write g of x or f of x as y, right? But everything on the other side is going to stay the same. Okay, so I replace g of x with a y. And now what I want to do is I want to interchange or switch x and y. So everywhere I see a y, I'm going to put an x. right? Everywhere I see an x, I'm going to put a y. So I get y plus 2 on top, and I'm still dividing everything by 3. So now what I need to do is I need to get y by itself. I need to solve for y, because if I could get y by itself on the right side, then I can figure out what the inverse is. So to get y by itself, I need to get rid of two things. I need to get rid of this 3 at the bottom, but I also need to get rid of this plus 2 on top. We're going to get rid of the 3 first. So to get rid of a 3 on the bottom, I'm going to multiply both sides by 3. Multiply both sides by 3. So that way, the 3 on the top and the bottom cancel out. And I'm left with a y plus 2. Y plus 2. On the other side, I'm left with a 3 times x, which is just going to give me 3x. So now the last thing I need to get rid of is the plus 2. And I can do that by subtracting 2 on both sides. All right. So when I do that, the 2's cancel out on the right side, and I'm left with y is equal to 3x minus 2. And now I pretty much solved for y, right? Y is by itself on the right side. Well, there is one more step I need to do. I need to replace y with a g inverse of x. So what's that going to look like? It's going to look like g inverse of x is equal to 3x minus 2. And I'm done. That's my inverse. Okay? So if my function is x plus 2 over 3, then the inverse of that would be 3x minus 2. And I'm going to verify that by composition. So let's take a look at that on the next slide. Okay, so my inverse was 3x minus 2. My original function was g of x is equal to x plus 2 over 3. And what I need to do is I need to make sure that when I compose the two functions, the inverse and the function itself, and when I evaluate at x, I still get x, right? So I'm going to put a question mark on top of that. Is it really equal to x? Well, that's what we're going to find out. So I start off with g inverse, composing with g, and evaluating at x. And what that's going to do is I can rewrite that as g inverse of g of x. There we go. So now what's g of x? That's going to be the x plus 2 over 3 up here. So inside g inverse, I'm going to have x plus 2 over 3. Okay, so what does that mean? Now what I need to do is I need to work on g inverse, which is up here. I'm going to replace every single x right here, which is just one of them, by the way. I'm going to replace this x with a x plus 2 over 3. All right, so when I do that, I get 3 times x plus 2 over 3, and then I have a minus 2 off to the side right here. So I'm going to subtract 2 at the end. So what happens there is I have a 3 on top and a 3 on the bottom. They will cancel out. So then I'm going to be left with the x plus 2 in parentheses still minus 2. And now you can see that the positive 2 and the negative 2 are going to cancel out as well. So these cancel out, and I'm left with x. Therefore, I get x back. That's great. So now I know that this is true, and I can erase the question mark because it's not in question anymore, right? We know it to be x. So that's how we verify that a function is the inverse of another function. Okay. Let's look at 3, 4, and 5. Okay, so for 3, I'm given h of x is equal to the cube root of x plus 5. And I want to find h inverse. Well, this is a cube root function, and it does have an inverse. We'll see that later. I'm going to replace the h of x with a y first, but I'm going to keep this side the same. So I'm still going to have cube root of x plus 5. Now what I'm going to do is I'm going to switch x and y. I'm going to interchange them. So I'm going to have x is equal to the cube root of y plus 5. So now I want to get y by itself, which means I need to get rid of this plus 5 right here. I'll draw an arrow to that. But I also need to get rid of this cube root right here. So how can I do that? Well, to get rid of a cube root, you're going to have to cube both sides. So I'm going to cube both sides. What's going to happen is I'm going to be left with x cubed on this side. And on the right side, the cube root and the cube as an exponent get canceled out. So I'm only left with whatever's on the inside, y plus 5. Okay, so now I'm ready to get y by itself. I just need to do one more thing, which is get rid of that plus 5. And I know exactly how to do it. I'm going to subtract 5. But make sure you do it on both sides, or it doesn't count. Okay, so the 5s are going to cancel out on the right side. And I'm going to be left with y is equal to x cubed minus 5. Now, I only have one more thing left to do, and that is to replace y with my inverse h of x, my inverse notation. So I'm going to have h inverse of x is equal to x cubed minus 5. So that's going to be my inverse. So isn't it interesting how I start off with a cube root and the inverse of that cube root is a cubic function? That shouldn't be that interesting to you because these functions are inverses of each other. They're opposites. So let's go ahead and verify that they are on the next slide. So for number 3, I was given that h inverse is x cubed minus 5. And my h of x is equal to the cube root of x plus 5. Right? That's my original function that I started off with. So now I just want to confirm that h inverse composed with h is going to give me x at the end. So is this true? Does it really give me x at the end? Well, we start off with h inverse, right? So we're going to have h inverse, and we're going to evaluate that at h of x. So we have h inverse. What is h of x? That is the cube root of x plus 5. So that's going to go on the inside. and then I close it up. Now what I want to do is I want to evaluate it at H inverse. So what that means is everywhere you see an X up here in H inverse, you're going to replace that with a cube root of X plus 5. So essentially what I get is the cube root of X plus 5 in parentheses. I have to cube it, right? So it's going to be raised to the third power, the whole thing. And then I'm going to be subtracting 5 at the end. So I'm going to subtract 5 at the end. So what happens here? Well, we have a cube root on the inside. We're raising that cube root to the third power. So actually, these 3's are going to cancel out. Whatever I have on the inside is just going to be brought out. The X plus 5. And then I bring down the minus 5. So what happens there? The plus 5 and the minus 5 cancel out to give me 0. So that's why I don't have to worry about them. They just give me 0. And the only thing I'm left with is X. And that's exactly what I wanted. So now I can get rid of this question mark. Okay. So the inverse of a cube root is a cubic function. That shouldn't be too surprising. Let's look at number 4. All right, for number 4, I'm given P of X is equal to 6 to the X minus 2 power. What I need to do first is replace P of X with a Y. That's always my first go-to step. Keep everything else the same for now. The next thing that I want to do is I want to switch X and Y. So everywhere I see a Y, like right here, I'm going to replace that with an X. Everywhere I see an X, like right here, I'm going to replace that with a Y. So I get 6 to the Y minus 2 power. Okay. So now I want to get Y by itself. There's a problem with that. There's this 6 down here. We're going to get rid of that first. And we have a minus 2 up here. We're going to get rid of that last. So how do I get rid of a 6 if it's the base of an exponential expression? Well, I have to take the logarithm of both sides, right? I have to take the logarithm base 6 of both sides. So I'm going to take the logarithm of the left side. So I get log base 6 of X. On the other side, I'm going to take log base 6 of whatever this is, the 6 to the Y minus 2 power. So what that does is it doesn't really do anything on the left side. I can't really cancel out anything. But on the right side, the base of the logarithm and the base of the exponential expression cancel each other out. And the log is going to cancel out with the exponential base of 6. And then I'm only left with the exponent, the Y minus 2. That comes down. Okay. So now I have Y minus 2. How do I get rid of a minus 2? I add 2 to both sides. Okay. So the 2's are going to cancel out on the right side. I'm just left with a Y. But then on the other side, I have log base 6 of X plus 2. That's going to be my inverse function. And to show that it's the inverse of P of X, I need P inverse of X. So that's going to be P inverse of X. That's not P raised to the negative 1 power. That's actually the inverse notation. And it's going to be equal to log base 6 of X plus 2. Okay, so that's the inverse function. Now what I'm going to do is I'm going to verify that they are inverses of each other. I'm going to do that by composition. So let's take a look on the next slide. I know that P inverse is log base 6 of x plus 2, and P of x is 6 to the x minus 2 power. So let's make sure that when we compose those, we get back x. Okay, so we're going to start off with P inverse, then we're going to move on to P of x. So P inverse comes first. I'm going to evaluate that at P of x. I know that P of x is equal to 6 to the x minus 2 power. That seems appropriate. I'm just replacing P of x with what it is, right? And what I need to do with that is I need to replace every single x in the inverse function with whatever's on the inside right here, right? So I'm going to get log base 6 of, should be x, but I'm going to replace that with this. So 6 to the x minus 2 power, and then plus 2 at the end. Okay, so what happens? Essentially, if you're taking the logarithm of an exponential function, the two bases are going to cancel out. So the base with the logarithm and the base with the exponential, they both cancel out, and the exponent comes down. And then I have x minus 2 plus 2. Well, there, the minus 2 and the positive 2 will cancel out, and I'm left with x, which is exactly what I was looking for. So I can erase this question mark. I know that the two sides are equal. Okay? All right, so the last one is going to be number 5. Q of x is equal to the natural log of x. So first of all, I want to find the inverse of the natural logarithm. And the inverse of a logarithm is always going to be an exponential function. So it's going to be some number raised to the power of x, right? So a to the x power. We just need to know what that a is. Well, luckily for us, we know what the natural logarithm is, right? It's log with a base of what? E, right? E being the exponential constant, Euler's number, 2.71828 ... Well, that's what E is anyway. It's an irrational number, so there's no way to write it as a fraction. But this is going to be the base for the natural logarithm. So it's okay if we replace this ln with a log base E of x, right? What I'm also going to replace is I'm going to replace Q of x with a y, but keep everything else the same. So all I did was I replaced Q of x with a y, and I replaced ln with log base E. Okay, so now I need to switch y and x. When I do that, I get x equals log base E of y. Now I need to get y by itself, which means I need to get rid of the log base E. How do I get rid of a logarithm? I do an exponential. So both sides are going to get the same base, E. So I get E raised to the x power, right? That's the left side. And I'm going to have the same base on the right side. It's just that the exponent is going to be log base E of y, right? So what happens here on the left side? Pretty much nothing. It's going to stay the way it is, e to the x power. But what happens on the right side? Well, the bases, the e's, are going to cancel each other out, right? So the e gets crossed off for the exponential expression, and the log base e gets canceled out because it's a logarithmic expression. And I'm only left with y. So at the end, I get y is equal to e to the x power, right? One more thing that we need to do. We need to replace y with the q inverse. So I'm going to get q inverse of x is equal to e to the x power. That's going to be my inverse function. So remember back when I said the inverse of a logarithm is always going to be an exponential. It turns out I was right. This is an exponential function, right? It's e raised to the x power. So some number raised to the x power. Now, the last thing we need to do is verify it. We're going to verify it by composition. So we always verify inverses by composition. Our inverse function was e to the x power. But our original function was natural log of x. So we need to make sure that q inverse of q of x is equal to x, because we're not sure yet. But we're about to be sure, right? So I'm going to start off with q inverse, and we're going to evaluate that at q of x. So what that means is I'm going to keep the q inverse, and I'm going to replace q of x with what it is, right? The natural log of x. So what that means is now I'm evaluating q inverse at natural log of x. So everywhere I see an x in q inverse, I'm going to replace that with the natural log of x. So that's going to be e raised to the x power, which is going to be the natural log of x, right? Okay, so now I'm going to rewrite ln as log base e, right? They're the same thing. And now I have a situation where I have a base of e for my exponential expression, and I have a log base e, so they're going to cancel each other out. Those two bases cancel, and I'm left with x, which verifies that these two sides are equal. So now I can get rid of the question mark. Okay, so that's function inverses, and I hope that helps you on the classwork.